Welcome to my channel. My name is Leo, and today let's do some more Leetcode problems. So this one is to find all possible recipes from given supplies. Let's read it. So you have information about n different recipes. You're given a string array recipes and a 2D string array ingredients. The ith recipe has the name recipes I, and you can create it if you have all the needed ingredients from ingredients I. So that's corresponding to the recipes I. And ingredients to the recipe may need to be created from other recipes, like ingredients I may contain the string that is in recipes. All right. You're also given a string array supplies containing all the ingredients that you initially have, and you have an infinite supply of all of them. Return a list of the recipes that you can create. You may return the answer in any order, okay? Note that two recipes may contain each other in the ingredients. So that means the ingredients were shared by all the recipes, and one recipe can become the ingredient, okay? Let's take a look at the example. So the recipe is bread, and it needs yeast and flour, and our supplies suggest that we have yeast and flour. So this is fulfilled, and we can make the bread. The second one, we have bread and sandwich, and the ingredients including yeast and flour to make the bread, and bread and meat to make the sandwich. So let's draw a graph on here. So we have bread, right? Also, we have sandwich. Okay, so to make bread, we need yeast and flour. To make sandwich, we need we need bread and meat. So our bread is what we built here. If we can build the bread, we can build the sandwich. But if not, we don't have the bread, we cannot make the sandwich. And let's take a look at the supplies. We have yeast, flour, and meat. Okay, so we have yeast and flour to make the bread, and then we put the bread into the ingredient or the supply with the meat to make the sandwich. So we should return bread and sandwich. Yes, that's correct. And I think this would be the same thing with this. So how do we solve this problem? It looks like we can draw a line here for the ingredients here. Why? Because we need to have yeast and flour to make the bread. So it looks like the course schedule where you have to take the first course in order to take this course in the second semester. Kind of like that. So it's typical that we can think of topological sorting. So does it work? So if we put this in the queue, put this in the queue, and we decrement the in degree and decrement the in degree, we can make this, and then we put that into the queue together with this. We reduce the in degree of this. Here, let me draw it here. We can decrease it, and I think we're good to go in that case. Okay, yeah. So let's do this topological sorting. So the first thing is we have to construct a graph. So here our key is string. So I'm gonna use a map with the string as the key and a list of string for the recipes. So this should be a mapping which leads the ingredients to the recipes it can make. or it is needed. Okay. Also, we have to make an in-degree array. And in this case, since the keys are all string, we also make it a map. And the number of the in-degree should be an integer. So I'm going to call it in-degree. Okay. Now let's construct the graph. Where are the ingredients? So they're in the ingredients, of course, right? So ingredients dot length. Oh, sorry, it's size because it's a list for every ingredients. I think it should first go through all the ingredients, right? So we need another looping variable to get each ingredient. J++. All right. So for the agency list, put if absent. What do we put in here? We should put the .get I, .get j. Okay. We should get the ingredient here as the key, and for the recipes it can make, we're just gonna put a new array list. After that, we can add the recipes to this map. Okay. So agency list get ingredients .get I .get j add recipes I. So this have to add bread as the value, and the flour also as the bread as the value. So this should be okay. And don't forget to update the in-degree. So in-degree dot get, it shouldn't be get. We can just put it down here. So recipes I. Okay, we have bread, and we're going to see how many times we put into it. So it should be in-degree dot get or default recipes I 0 + 1. Okay, great. Now we're good to go. So we have the graph with the ingredients to the recipes. And what about the supplies? The supply, we are going to put it into the queue. Okay, so we are construct the queue, initialize the queue for what? For topological sort. Okay, so now we have a queue with strings in there. It's going to be a new linked list. And what do we put into the queue? So for the in-degree and in-degree dot size. Oh no, we don't have to do that. We can just put the supplies into the queue. Yeah, it's used to store supplies. Okay, good. So for string s in supplies, we're going to add them into the queue. Okay. Also, at this time, I think it's proper to construct our result, because we're going to get some results from the queue. Okay. All right. And next part is the expansion. Okay. How do we expand? Well, queue is not empty. We're going to pull it out. right? So string supply is q equals to q dot pull. Okay, we can pull the supply from it, and we have to go through all the recipes it can make and detach this integrity for the recipe. When it can be made, we put it into the queue. Okay, yeah, sounds good. So for string recipe, just a list dot get supply. We have to put the integrity down. Okay, so integrity dot get supply. Sorry, well, no, recipe, and we put it back. Recipe in degree. Okay, if in degree dot, I just use this. If the integrity is 0, we are going to add it to the queue. Also, that means we can make this recipe. So we have to add it to our final list. Okay, so result also will add the recipes. Well, there could be one problem here. Maybe we don't need something like we make bread and sandwich and burger, but like sandwich is never used. In that case, we should just let it continue. Okay, we should just skip it. So if the supply is there, how to denominate the string is not needed. So if it's not in the adjacent list, right? Yeah, it's not needed. Contains key supply. Continue. Okay. All right. So this should give us the right answer. We're going to return the result. Let's take a look. Okay, I think it passes. As for the space complexity and time complexity, I think we looped through all the like the edges of this graph and all the nodes of this graph. So it should be v plus e. Okay, and as for the space, we have a queue, which saves all of our supplies. In the worst case, all of the vertices should be there. And since we're doing a topological sort, we manipulate the edges, so it should also be v plus e. Okay. Let's submit it. There we go. All right. That's great. Hope you understand this, and let's see you in the next video. Thank you.